So let's go to the first one. Let's go to the explanation of degree of freedom. And degree of freedom is number of components of motion that are required in order to generate motion. So example just now, I showed you the example of slider and crank. So this first figure shows the joint with only one translational degree of freedom. It means that it's going to move in one direction. So when one direction means that it's 1 degree of freedom. So if you have two motion, example, this one is going to move in linear and you have another n effector here is going to rotate. Okay, so this what we call as 2 degree of freedom. Okay, so these are the main component. But normally in robotics, you normally have 6 degree of freedom, lots of degree of freedom. So let's look at the first one, which is the linkages. In linkages. So this example of crankshaft just now I showed you, but we go by parts. So linkages, or we call it as the kinematic chains, is each part of a mechanism which has motion relative to some other parts in terms of link. So it means that we have a link there in between and it's connected to that part by one point. So a rigid body which has 2 or more points or attachment to other is determined using the term knots. So if you see here, this is a link, okay, and you see that there's a hole at the end here, so we call that as a knot, where that's the point where it's going to rotate. Okay? So each link is capable of moving relative to each neighboring link. Right? A joint is connected between the connected link at their nodes, which allows some motion. So at this link here, okay, a joint will be connected here. So that joint will actually be the one movement. So for example, your elbow, if you are going to develop a robotic arm, so you have the link, your link, this one link, another link. So you have the joint here. So the joint is the one that connecting the link here. Okay. So example is lever, crank, connecting rods and pistons, slider, pulley, belts. So all of those have links, and the joints. So kinematic chains is a sequence of rod, joint, and links. So example here is the simple engine mechanism. So we have the crankshaft and we have the slider. So I just go through because I explained just now about the design of many mechanisms are based on 2 basic forms of kinematic chains. So 2 main things. So it's either 4-bar chain or 4-bar link or sliding crank chain. So sliding crank chain is normally to convert from rotary to linear, and 4-bar chain can actually convert from linear to linear or linear to rotary or rotary to linear. Okay? So this one, I think I already explained just now, so I just skip. Okay, so this one is the front view, and this one is the side view. Side view. So if you see here is that which one is fixed? Which one is fixed? Hello?
Number 3.
Number 3. Okay, good. Number 3 is fixed. Number 3 is actually the shaft there. The shaft is connected to to the block over here, so it's going to be the one that fixed. One is actually the crankshaft. Circle that. So the crankshaft is going to rotate across the shaft there. So going to rotate, and because the crankshaft is connected to this link, okay, by a joint here, this joint. So and it's connected. The joint here is connected to the cylinder. So what happens that when this rotates, it's going to move the slider up and down. And if you see to the right side over here, at the right side, you see that the slider is, how can the slider move up and down? Okay, as mentioned just now in the video, okay, you need to have a guide to guide the mechanism. So where is the guide? So this is actually the guide. This is the guide. Okay, the cylinder is the guide for the cylinder. Sorry, not the cylinder. the cylinder of the engine, okay, is the guide for the slider moving up and down. Okay, this is cylinder. Imagine that you have a cylinder, and this is, of course, this whole thing is inside here. Okay, so this cylinder will be the guiding system for the slider to move up and down. Right. So hopefully you can imagine this figure lah, because I think most of you already taken the AutoCAD. Yeah, have you taken AutoCAD? AutoCAD, the 2D and 3D. Have you
Yes.
taken AutoCAD? Yes, eh? So if you are taking AutoCAD, I'm sure you can imagine this diagram perfectly, yeah? Because AutoCAD, you have to understand the front view, the side view, the top view, the 3D view, right? So this is where AutoCAD, you are going to apply that knowledge or skill of AutoCAD into this subject. And okay, this one is example of slider crank chain, and we have the 4-bar chain. So 4-bar chain is like what I explained just now. 4-bar chain is where you have, okay, the end of this point, for example, this joint, and this joint is going to be fixed. Okay, and this one is also going to be fixed, and it's going to be fixed. So the first one, the second one, and the third one. Okay, for this first one, is going to actually transfer rotation from rotary to rotary, right? So this one is going to be fixed and it's going to rotate apart this axis, so it's going to rotate. And for level crank mechanism is that where this link over here is actually connected to this joint and is connected to a crankshaft. Jadi crankshaft. Just imagine that just now we have the crankshaft, this crankshaft. Okay, so it's similar. You have this crankshaft. So this point is actually joined together. So what happens is that when this crankshaft rotate along this form, then it's going to give a motion to this point. So you're going to go left and right, left and right. And for the third category will be where you have both sides. Okay, this one is the fixed. Both sides you have the crank, you have the crankshaft. So it's going to be fixed here and fixed here. It means that it's going to rotate. It's able to rotate full degree. And this one is an example of another example of 4-bar chains, where if you see here, okay, you have this crankshaft connected to a link. Okay, so means that which one is the second one, level crank mechanism. So this level crank mechanism, when it rotates, what happens is that it's going to, this is what what is this? What mechanism do you think is this? What mechanism? Pernah nampak tak mechanism? Do you know the English term I do not know, but piring hitam last time or you can see in our disk drive. This drive is actually using this mechanism to read and write. Okay, so what happened is that when this move, okay, because of this is going to rotate left and right. This lever here will actually move left and right, or you can actually move it upward. Okay, so this is a film lah. It's going to read and write or play the video or play the sound. So this is where it will read whatever that you have saved on top of the film. So it's going to, if you see here, it pull it forward for releasing and move up and back to lock the film. Okay, so the mechanism used in a film. Okay, And this one is an example of for batching for toggle position. So toggle position is where, if you see here, let me just see, okay, it's being used in the tailgate of a truck. Okay, tailgate of a truck. So if you imagine that this is a truck, this is the head body of the truck. You have the wheel over here. Okay, sorry, my drawing is really bad. So this is truck. Okay, so you have the truck body here. So what happens that this one is the fixed part. Okay, and it's connected to using a 4-bar link. So you can actually put a motor over here, and the motor will actually rise it either this at 0 degree angle or to the maximum 90 degree angle.